1.8, exploring similar solids. So remember back to similar figures. They essentially look the same except for one is bigger than the other, but it's bigger by a ratio. So like all side lengths are 2 times longer, or all side lengths are 1/3 times longer, okay? Or shorter in that case, right? So same thing here. So we have 2 similar solids, so 3-dimensional figures that are similar. So they're going to have a ratio. Like maybe this one is 50 inches cubed for the volume, and this one's 3 times bigger, so it'd be 150 inches cubed for the volume, something like that. So it'd be a ratio of 1 to 3, right? Okay, so 2 solids, similar solids, 2 solids that have the same type, with equal ratio of corresponding linear one-dimensional measures such as height and or radii. If 2 solids have the same scale factor, or have a scale factor of A to B, so A to B, whatever number this is to that number on the next one, then the solid surface area have a ratio of A squared to B squared. And their volumes have a ratio of A cubed to B cubed. Okay? So solid A, number 1, solid A is similar to solid B with the given surface area and volume of solid A. Calculate solid B's surface area and volume essentially. So here's their scale factor. It's a ratio of 1 to 2. So if we're thinking about surface area, what would the surface area ratio be? A squared to B squared, so it would be square both of them. What do we get, guys? 1 to 4. 1 squared to 2 squared would be 1 to 4. Does that make sense? And what would their volumes ratio then be? 2 times 2 times 2. Yep. 1 to 8. Okay, easiest way to do these is set up a proportion. So this guy over this guy. So the scale factor of this guy is 42 pi. That is A's scale factor. They want us to find B's scale factor, which we don't know, right? But we know the ratio is what to what for the scale factor? 1 to 4. This is for scale factor. Or sorry, this is for surface area. We're using this scale factor. Okay, how do I solve that? Yeah, what's 42 times 4? So it'd just be 168 pi equals, what's 1 times x? There's your answer. That is for the surface area of the second figure that would be similar to this, but obviously bigger, right? How am I going to set up the volumes proportion? What over what equals what over what? There you go. Cross multiply. I get x equals, what's 36 times 8? How much? Thank you. So this would be 288 pi, and that is for the volume. Feet cubed. Up here would be feet squared. Okay. Try B on your own. Okay, let's try this one. So what would the scale factor for the surface area be on this guy? 4 to 9. And what would the volume ratio be? 8 to 27. Did you guys get that first off? Perfect. So scale factor of the A, figure A, is 75.6 over x equals 4 over 9. There's going to be a little more math here because you actually have to cross multiply and divide this time. So we get 4x equals 680.4, right? Divide by 4. So surface area equals 170.1. Is that what you guys got? And that would be what? Centimeters squared. And then volume would be 36 over x equals 8 over 27. So 8x equals 972. Divide by 8. X equals 121.5 centimeters cubed. Any questions on that? Okay, I want for you to try 2a and 2b real quick on your own. So I just started by writing 28 pi over 63 pi equals a squared over b squared. A is this figure, so it's my A, and then this is my B, so that's my B. Does anybody know what you do at that point? Kinda, not really, a little bit. You want to square root a squared to get it down to a, right? So you're going to square root that. You want to square root b squared to get it down to b, so you're going to square root that. What is the square root of 28 pi? Round to the nearest hundredth. 9.38. And what is the square root of 63 pi? Yep. There's your ratio. If those were whole numbers, then you would reduce them down if you could. We have decimal numbers there. Okay. We're going to set up this similar. 54 inches over 16 inches equals A. This is volume now, so it's A cubed over B cubed. So you're going to find the cubed root of 54, and you're going to find the cubed root of 16. What'd you get for the cubed root of 54? It's a funky number. Anyone? Cubed root of 54? Do you know how to put that into your calculator? Yep. And the cubed root of 16? Good. Yes, sir.
Okay, so trying to straight up simplify 54 over 16, you get 27 over 8, which would be a cubed over b cubed.
Homework for this section will be pages 13 and 14 in your supplemental packet. And the homework for the previous section was pages 11 and 12 in your supplemental packet.